Good morning, student. I am Mrs. Rushali Chaudhary, lecturer Praveen Patil Polytechnic. Today we are going to learn applied chemistry practicals under subject code 22211. This is applied for the electrical and electronics group for the second semester of diploma engineering. This is your first page of the manual. This is the certificate page. Here we are going to perform the 8 experiments. Today we are going to perform the experiment number 1, that is the alkalinity of a water sample. What is meaning of the alkalinity? Different hydroxide basic group ions are present in the water. Due to that, the water become alkaline. And if we use alkaline water for the industry like a textile, paper, sugar, pharmaceutical, it will change the result. We will not get a desired product, and due to the alkaline water or due to the hard water, the metal parts undergo corrosion, caustic embrittlement, scale and sludge formation. To avoid it, we must know how much alkalinity present in the water. Accordingly, we are going to add suitable acidic medium to get it neutralized to convert water into the soft water. It is required for the corrosion prevention. Minimum theoretical background. What is meaning of that? How the alkalinity of the water is produced. How it is produced? It is produced due to presence of OH minus, CO3 minus and CO3 2 minus, HCO3 minus. That is a carbonate and bicarbonate ions and hydroxyl ion. These three ions are responsible for the alkalinity of water, and we are going to determine how much exact quantity of OH minus, CO3 2 minus and HCO3 minus is present in the water. For this, we are going to use a two indicator to determine this. First, we are going to determine OH minus concentration by using an indicator called as a phenolphthalein indicator. Then after same solution, we are going to determine how much carbonate, bicarbonate is present. That is by using methyl orange indicator. Resources. The material which is required for this experiment is Buret, conical flask, beaker, pipette, hydrochloric acid, and we require the two indicators, phenolphthalein indicator and methyl orange indicator. We are going to follow all the precautions as it is a titration. We have to wash all apparatus properly with the water. With the distilled water, you should add titrant slowly in a solution. This is an actual setup of practical. This is called as a Buret. It is made up of glass and it is having a marking as from 0 ml to the 25 ml or the 50 ml. 1 ml marking is there. Here we are going to fill 0.01 normal HCl. Sample solution. The test solution we are taking in a conical flask. This is called as a conical flask. We are taking the sample solution. See here, first we take on a Buret. We are going to fill the Buret with 0.01 normal HCl. That is the standard solution. And in a conical flask, this is conical flask, we are going to take a sample water. And indicator is phenolphthalein. For the first titration, we are going to take a phenolphthalein indicator. First, we are filling the Buret with a 0.01 normal HCl. Remove the bubbles and then after take a 25 ml of water sample in a conical flask. Add phenolphthalein indicator. When we are adding the phenolphthalein indicator, the solution color is become pink. And then we are going to add dropwise HCl from the Buret till it becomes colorless. This is called as a phenolphthalein endpoint. So initially when we are adding the indicator, we will get a pink color solution due to the presence of OH minus ions. But when we are adding the HCl, OH minus is get neutralized and color changes to the colorless. And the point where the pink color changes to the colorless, that quantity of the HCl is called as phenolphthalein endpoint. We will note down this reading in an observation table. Then after in this solution, we are going to same solution. We are going to add methyl orange 2 drops. When we are adding a methyl orange, we will get yellow color. Again we are going to continue the solution till it become orange, and we will note down the reading when it changes the color to the orange, and that is called as methyl orange endpoint. Here in the first observation table we write down that is the first reading is 1.4, means when we are adding 1.4 ml of HCl, the color is become transparent. That is called as a phenolphthalein endpoint. Similarly, we are going to take 3 readings. But after this, we are going to continue for the second titration with the same conical flask using a methyl orange indicator. So when we are adding a methyl orange, the solution is become yellow. But we are going to add HCl till it become red. So here we will observe at a 4.2, the solution is become red. So that is called as a methyl orange indicator. Value of P is equal to 1.3. We will take an average of these 3 readings. And for the M, we will take a average of these 3 readings. Accordingly, we will put a value for the OH minus in a calculation format to find out exact quantity of OH minus. Simultaneously, for the carbonate also, we are going to put a value in a calculation format to get an exact carbonate ions. We will write down our results in a result format. Practical related questions that we will get from the minimum theoretical background. Which ions makes the water alkaline? OH minus, CO3 2 minus and HCO3 minus and CO3 2 minus. This makes the water alkaline. Thank you class. Thank you for listening. Thank you so much. बोल